Now once we have our surfaces done inside of Alias Design, we need to bring them into our engineering CAD software so that we can start doing the engineering work on our design. One of the really nice things that we have inside of Inventor is the ability to associatively import those surfaces. So opening up the wire file allows us to bring those surfaces in and sculpt it into a solid model. And what's really important here is that now we can make any changes that our industrial designer makes to those surfaces in Alias, we can automatically update inside of Inventor. Now that we have our solid model sculpted from the surfaces that we brought in from Alias, what we want to do is start creating our individual parts. Now typically this process involves creating a master model like we have here and then deriving that into each individual part of the assembly. This can be a very time and labor intensive process of constant derivation, trimming off the areas of the master model that aren't needed for a specific part, and then re-importing all of those different parts back into a final assembly. Now what we have inside of Inventor is really nice is the ability to create multi-body parts. So even though we're still in an IPT, an Inventor part file, we can start splitting this body into multiple parts. And here you can see I've already split the handle from the main body, I've split the lid, now I'm splitting away the two parts that are going to make up the base and the heater for this kettle. So one of the very important things that we want to do next is shell it out. So even though we've brought those surfaces in and they're very, very complex, you can see that Inventor shells all of them with ease at a thickness suitable for injection molded plastics. And I'll go through and I'll shell out all of these different components. And now I'm going through and I'm just shelling out all the different components. There I shelled out the body at 2 millimeters. I'll again shell out the heater base at 2 millimeters. And finally I'll shell out the base of the kettle at 2 millimeters. So now I've got all my parts shelled out. I want to do one final split on this handle to split this in half because it's going to be two separate components. And now what I actually want to do is I want to combine the lower portion of that handle back in with the base because that's a component that could be molded all as one part. I can come in and rename all of my different solid bodies accordingly. And then because we created all of these different solid bodies in a single part file, what we need to do is make components. And this is fantastic because it's a huge time saver in the fact that we no longer have to derive all of our individual parts and then re-import them into assembly. By splitting them here, I'm able to define all of the part structures, including the template that we want to use for the different parts, as well as the file location, and it's automatically going to create the assembly with all these parts in place. So I don't have to deal with constraints, I don't have to deal with all of the work involved with re-importing all of these parts into a master assembly and coming back with all the work. So now that I have my assembly, I want to start doing some engineering work. And here you can see I've already done a little bit, but what I want to highlight is some of the plastic features that we have available to us inside of Inventor 2011. So the first thing we're going to do is create a lip on this handle, which is a very common feature in plastic parts when you're assembling two parts together. The problem is creating these is typically a very time-intensive process of creating multiple extrudes, offsetting surfaces, and then finally trimming away the areas of those extrudes that you don't want to keep. Now with the lip feature, it's a very, very simple process. We pick the edges that we want to use for the lip, we define the profile as well as the starting and end points of it, and we create it as a feature in and of itself. Now another one of these that's a common feature is the boss. Now bosses, again, are typically things that you create a cylindrical extrusion, then you have to create a hole, you have to offset surfaces if you want different, if you want to have any landing areas. But here what you can see in the boss dialog box is all of those parameters are defined, so all you need to do is punch in the dimensions of the boss that you want, hit OK, and you can even come in here and add rib features to it all at once. So again, we don't have to do multiple features to create one engineered feature on the part. If we want to create a boss, we tell it we want to create a boss, and then we add in any of the additional features that are necessary. So again, a huge boost in improvement using all of these plastic features to help you design the engineered component rather than focusing on the CAD process involved in doing that.